The second type of trig equation we're going to be dealing with are those that involve multiple angles. And we're going to use, once again, the same procedure that we did before where we take arc sines, we're going to find reference triangles, we're going to add plus 2 pi n's when it asks for all solutions. But now we've got one additional step, and it's going to be what happens when there's a 2 or a 4 or something that's attached to the x. So before we look at that, let's draw a quick sketch of these three graphs: sine of x, sine of 2x, and sine of 4x. We know that the sine of x from 0 to 2 pi, and we're just going to do this from 0 to 2 pi for each of these, and we're not going to include 2 pi, is a hill and a valley for sine. And if I look at the number of solutions that we have, I've got one spot where it crosses the x-axis there, and one spot where it crosses the x-axis there. So I get 2 solutions. Remember, since I've got this parentheses here, I'm not going to include the piece that's at the end. If I do the sine of 2x, so I'm going to have 2 hills and 2 valleys. And once again, since we're doing 0 to 2 pi, I'm not going to include the point that's at the end. I see there's a solution there, a solution there, a solution there, and a solution there. So I see 4 solutions. Finally, if I do sine of 4x, 1, 2, 3, 4. There's 4 hills and 4 valleys, and I'm not going to include the point at the end because, once again, we're not including 2 pi. 1, 2, 3, 4, 5, 6, 7, 8. I get 8 solutions. So there seems to be some direct correlation to the number of solutions and the coefficient that's attached to the x. And that is the case. When we have a constant that is larger than 1, you get this horizontal shrink between 0 and 2 pi, which means you get more cycles from 0 to 2 pi, which means you're going to have more solutions. And the relationship that we're going to see with most of these is that whatever we have inside there, we're going to take 2 and multiply it by that. So we're going to double whatever we have. So if this were to have been sine of 8x, I'm going to get 16 solutions. If this were to have been sine of 3x, there would be 6 solutions. So with regards to the original function, how do the number of solutions change as you add constants in front of the variable inside the function? And the answer is that we're going to increase solutions or decrease solutions. These are all the increasing solutions perspective. But let's say this were to have been the sine of half x. That would mean I only get 1 hill in from 0 to 2 pi instead of a valley as well, and then I'm going to only have 1 solution instead of 2. So our process is going to be the same as before, but there's only one piece that's different. We are going to divide through or multiply through by whatever is inside the sine or cosine, whatever is attached to that x. We're going to multiply or divide through that as my very last step. But that's going to be after you put in the all solutions piece. That's after you put in the plus 2 pi n. Then you divide through. That is huge. Highlight that if you've got a highlighter. Do something with that. That is a huge piece. You multiply or divide through as the very last step after you put your plus 2 pi n's, after you do all your reference triangles. You multiply or divide as the very final step. So we're going to solve the following multiple angle equations for all solutions in pi radians. Check your work graphically and algebraically. The checking your work graphically and algebraically is the same as before, where you take your answers and plug it back into the original. And your graphical is where you plug in y1 as being the left-hand side and y2 as being the right-hand side, and then see where the intersection is. So I'm not going to do that every single time here for sake of time, but realize that is the way that it's done. So here we're going to solve for theta. And I'm going to get the trig function by itself. Same first step as before. So I'm going to subtract 1 to the other side, and I'm going to divide by 2. So I'm left with the sine of 2 theta is equal to -1/2. At this point, I cannot divide by 2 here because I still have the sign on the outside. What we do now is we're going to take the arc sine to both sides. So same step as we had before. Arc sine and sine cancel out, so I'm left with 2 theta is equal to the arc sine of negative 1/2. At this point, I still don't want to divide by 2. That dividing by 2 is going to be the very, very last step in this problem after I do all my reference triangle work, after I do everything else. So here, this arc sine of negative 1/2, let's pull over the calculator, and we'll do the arc sine of negative 0.5, which I can see is a negative 30 degrees. But since we are in radians, we've got to convert that to radians, which is pi over 6. And we know that sine is going to be negative in the 3rd and the 4th quadrant. So my 2 angles there, we've got pi over 6 reference angles. So if I look at that and I go around my unit circle, I know this is pi, which is 6 pi over 6, and that's 1 pi over 6 past that. So I know that 2 theta is going to be 7 pi over 6 plus 2 pi n. So it's the exact same setup as we had before, but we still have that 2 in front of the theta. And then this guy right here, we know this is 2 pi over here, which is the same thing as 12 pi over 6. And this is 1 pi over 6 before that. So this would be 2 theta is 11 pi over 6 plus 2 pi n. So now that I've got these 2 answers of 2 theta equals 11 pi over 6 plus 2 pi n, and 2 theta is 7 pi over 6 plus 2 pi n, I can finally divide everything by 2. If I divide this guy by 2, we now get 11 pi over 12 plus pi n. That's my first solution. And down here we'll divide by 2, which would mean theta is 7 pi over 12 plus pi n. Now you might say, well, when I divide by 2, doesn't this 11 sort of become like a 5.5 or something? And it's not quite like that. If you're not sure how that divided by 2 came about, think about dividing by 2 as multiplying by 1/2. If I had 11 pi over 6 plus 2 pi n, and instead of dividing by 2, think of multiplying by 1/2. And when I multiply by 1/2, I can clearly see that's 11 pi over 12. And then here, 1/2 times 2 is just 1. So if you get confused by that division, think of dividing by a number is the same thing as multiplying by that fraction. So that's going to give me all solutions in pi radians. There are my answers. Now, let's say that this problem were to have said finding the following multiple angle equations, the answers from 0 to 2 pi. If it were something like that, we would still be going through the same process that we just did. But remember, this n indicates 0, 1, 2. What we would have to do then is we would take our theta equation here, and we would say let n equal 0. So 11 pi over 12 plus pi times 0, which would be 11 pi over 12. And then we would say n equals 1. 11 pi over 12 plus pi times 1 is 11 pi over 12 times a common denominator would be 12 pi over 12, which is 23 pi over 12. So if it said I was looking for the answers from 0 to 2 pi, instead of all solutions, what I would be doing then is I would first find my equation with that plus 2 pi n, or this plus pi n in this case, and then I would go through and substitute in values that make my equation true. If I were to plug in a 2 here, 11 pi over 12 plus pi times 2 is 11 pi over 12 plus 24 pi over 12, which is 35 pi over 12. And that can't be a solution because that's larger than 2 pi, because I only wanted 0 to 2 pi. And then I would do the same thing for the other equation, the 7 pi over 12 plus pi n. So if I wanted to know specifically a group of answers from 0 to 2 pi or 0 to pi, I would then go to my process of plugging in n equals 0, n equals 1, n equals 2, n equals negative 1, n equals negative 2, and finding all those solutions that make the equation true. If I have it say, like I do right here, for all solutions, you just box your answer and leave it as it is. But realize if it were to say from 0 to 2 pi, I would need to find the individual solutions.